Good afternoon, everyone, and welcome to Asteroid Day 2020, hosted by the Krista McAuliffe Center for Integrated Science Learning at Framingham State University. We're very excited to have you all with us today, and we hope that you will join us for future live events. This is one of many live events that we have done virtually in the past few months. You can find information about this event, resources related to it, and future upcoming events at our website, cm-center.org. We actually have events going on, or at least one other event going on later today. We have activities that you can do at home, and we have other live events coming up later in the month. I am the Planetarium Programs Coordinator. I am the Planetarium Program Manager at the McAuliffe Center, and I host a bi-weekly program called Astro Nights, which is every other Friday at 7 p.m. But for today, we are here to observe International Asteroid Day. And joining us is our guest speaker, who has been involved in science education for many, many years, and with us for many years, including many past asteroid days. So I'd like you all to welcome Pat Monteith. She is a NASA JPL Solar System Ambassador and published author. And we are all very excited to hear from Pat today. So go ahead and take it away.
All right, well, first of all, my computer screen is only about 3 feet away from me, so I think I probably have to put on my mask. Do I have to put on my mask? Is that required? No, probably not, because it's virtual, huh? Okay. So, yeah, let me see if I can share my screen right now, and if this will. There we go. All right. And that's perfect. All right. So as Mary said, we are here today to celebrate Asteroid Day, which we'll talk about in a little while, and why it is celebrated on June 30th every year. And I have actually been doing an Asteroid Day presentation for, this is, I think, the 5th year now. And it started when an organization called the B612 Foundation got involved in celebrating Asteroid Day. And the B612 Foundation is headed by an astronaut by the name of Ed Lu, who was just fascinated with all the craters that were created on the moon from asteroids over the years. But maybe we'll get into that another time, but not today. Okay. There we go. All right. So as Mary said, my name is Pat Monteith. I am a Solar System Ambassador, which means that I was selected by the Jet Propulsion Laboratory staff almost 4 years ago to be a volunteer for NASA and for JPL, to go off and do presentations like this at libraries and schools and community organizations like the McAuliffe Center. And I'm so happy to be here today. When I got a call from the director of the McAuliffe Center saying, "Are you interested in doing something this year for Asteroid Day for us?" I was really, really excited about it. I'm also an author. I wrote a book 3 years ago for middle school students called The Secret Case of the Space Station Stowaways. And that's where I learned a lot about asteroids, because one part of the book deals with asteroids. And if you haven't read it, then I'm not going to give the story away. All right. So, the title for today's presentation is, the hunt for asteroids. And so the question is, why would we want to hunt for asteroids? But first, let's start off by a little bit of a poll here, see if we're all on the same page about what asteroids are and aren't. And 3 of these pictures depict an asteroid, but one of these doesn't. And my trusty navigator, Mary, back at the McAuliffe Center, is going to put a poll up that will get you to select which one of those four photos do you think are not an asteroid? Is it A, B, C, or D? I'll give you a couple of seconds here to sort of figure this out. Okay, some people are saying B, some are saying C. What do you think? You get a chance to select one of those four options in terms of which one do you think is an asteroid or not. Okay, so most of you, 78% of you are saying it's option B, 22% are saying C, and can we share the results there? There's the results right there. All right, so those of you who said B is correct, and we'll talk about what that item is, what that celestial object is in a second here. And you'll see that C, in fact, is an asteroid, and so is A and D. A is Asteroid Bennu, which we're going to talk about in a couple of minutes, and we'll talk about the item D, which is the Psyche asteroid, and we'll learn about that in a little while. So can you get that? Okay, I get that off my screen. Great. All right, so let's talk a little bit more about asteroids and the difference between comets and asteroids, because a lot of people think that comets are and asteroids are the same thing when they're really not. So comets, and as you could see, that was the picture that was up on the screen, are small objects that maybe are 12 miles across. And I'm sure some of you are saying, 12 miles, that's not small. It's not a short distance. But in space, 12 miles is a very, very, very short distance. And they've collected ice and cosmic dust, as well as gases such as helium, methane, and hydrogen. And as a comet passes the sun and heats up, the gases and the ice are released, and they reflect what you're seeing here, a tail, as a result of the solar radiation. Now, just the opposite, asteroids are usually made up of rock and metal, and they orbit the sun like tiny dwarf planets. And some contain water and chemical material that scientists believe can create life. And the largest asteroid in the asteroid, well, you'll see what the asteroid is Ceres. And Ceres is actually 300 miles across. So there's a lot to do with asteroids and a lot to learn about asteroids. Let's briefly look at some asteroid terminology here. You know, comets, as I just said, is a solid body made up of ice, rock, dust, and gases. Asteroids are usually large, very large, rocky iron or metallic debris flying in space. Meteors, the light coming from an asteroid as it enters Earth's atmosphere is a meteor. And some of you also probably know that as a shooting star. So if you've ever looked at the night sky and you saw something streaking across the night sky, I'm sure you're saying, oh, that's a shooting star. Well, it's actually a meteor. And when you see a lot of meteors coming at you at once from the same point in the sky, usually over a period of a few days, that's called a meteor shower, like you see here. And if a piece of the asteroid doesn't get burned up as it's entering the Earth's atmosphere and hits the ground, it's called a meteorite. And then there are near-Earth objects. And these are asteroids with an orbit around the sun that gets very close to Earth. And we'll talk about those in a minute too. Asteroid hunting has been around for a long time, since the late 1980s, with the Galileo mission, which was the very first mission that NASA launched. It wasn't particularly looking for asteroids. Matter of fact, it was on its way to study Jupiter and its moons, but it flew by 2 asteroids. So it sent some information back to Earth about the 2 missions, about the 2 asteroids. Since then, you can see there have been 8 other missions to asteroids. One of the more recent one is the Dawn mission, which went to Ceres, the asteroid we saw a little while ago, and another asteroid called Vesta, and the Dawn spacecraft is still in uncontrolled orbit around Ceres, but has sent back an awful lot of information, including about the fact that both Vesta and Ceres has water on it. 2 of the more interesting missions are the last 2, the Hayabusa 2, which is a Japanese spacecraft, and the OSIRIS-REx mission, which these 2 last missions are actually going to the asteroids. They're going to be picking up a sample of the soil from the asteroid and return it back to Earth. Hayabusa 2 is actually due back to Earth late this year, sometime I believe in December, and OSIRIS-REx will be on October 20th. We'll be touching down on Bennu and picking up the soil, but it won't be back to Earth for a few more years in 2023. All right, so we know how long we've been looking for asteroids. Let's learn a little bit about where the asteroids come from. And I believe you probably all know what the solar system looks like. And there's the sun and the 8 planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And but then I believe some of you may know where the asteroid belt is and where the asteroids come from. But I'm going to turn this over to my trusty navigator, Mary, who's going to talk to you and show you about the asteroid belt.
Okay, thanks, Pat. So yeah, so we're all used to seeing pictures like this. Anytime you see a picture like this, there's always something about it that's not quite right. This picture is not quite to scale. And one of the and that's very common in little cartoons of the solar system. One of the things that's definitely not quite right about this image is that there's actually a lot more space between the planets, and there is particularly a lot of space between the planets Mars and Jupiter. And that was something that was rather mysterious to scientists and everyone for a long time, which is why there was this large area in the solar system where there appeared to be no planet. So we're taking a look at a slightly more to scale view of the solar system, where you do see a more accurate spacing of the locations of the planets in their orbits. And also the fact that you cannot see the planets themselves at all is more accurate, because if you were this far out in space, you certainly wouldn't be able to see the planets. But if you want to get a quick look at one, I can make a planet nice and big for you. That's a little too big. Okay, so I mentioned that there's this big space between the orbits of Mars and Jupiter. We're going to get a little bit closer to that area. And this region between Mars and Jupiter is the area that is known as the asteroid belt. So there is no particular planet in this region, but at one point there was an object that was discovered there, known as Ceres, which you've heard Pat mention. It orbits right here. And when it was first discovered, Ceres was indeed called a planet. But soon it was clear that Ceres was just one of many objects in this region, and they're now known as asteroids. So what I'm going to do is I'm going to turn off the stars so that you don't get confused. And now I'm going to turn on the asteroids. What I'm going to show you is not accurate. So remember, we talked about things not being accurate. I'm going to show you basically the locations of many of the known asteroids. But this is not at all what they look like. They are not these beautiful colors, and they are certainly not this bright. It's actually quite difficult to observe asteroids. They are very small, and many of them are incredibly dark and hard to observe. So the majority of the asteroids, like Ceres, and then, I want to mention one more. The second largest asteroid in the area is known as Vesta. Most of them are located in this region, which is known as the main belt. So they exist in nice, stable little orbits between Mars and Jupiter. But there are some that have slightly different orbits. So for example, some of them, and let's get a little bit closer so we can see this. Some of them cross into the orbit of Mars. So see this purple one I've just mentioned, this is the asteroid Eros. This crosses the orbit of Mars. It's known as a Mars crossing asteroid. And then some of them actually cross the orbit of Earth. And that is the case for the asteroid Bennu, which I know you are going to hear a little bit more about today. So these Earth crossing asteroids and asteroids in general that come close to Earth are the ones that a lot of scientists and other people, including policymakers, are really interested in for obvious reasons. So that's your little quick introduction to the solar system and the asteroid's place in the solar system. And now I'm going to turn it back over to Pat. Pat? Unmute.
Sorry about that. I think I didn't mean to do that. Okay, you should be hearing me now, correct?
Can't hear you.
Can you hear me now?
Can't hear you.
I can hear you just fine.
Oh, okay. All right. Okay, perfect. All right. So, we talked about, or Mary just talked about where the asteroid belt is, which is great. And we know these rocky bodies are up there. But, the question comes to why in the world would we want to hunt for asteroids? Why does that make a difference here? And one of the asteroids that Mary just mentioned that has turned into be my favorite asteroid mission is NASA's OSIRIS-REx mission, which is a spacecraft that's going to the asteroid Bennu. And OSIRIS-REx is an acronym, and an acronym is each one of the letters in the title stands for something else, and in this case it stands for origin, spectral interpretation, resource identification, security, and regolith explorer. Okay, so we're not going to get into the details of that, but it's a really, really fascinating mission for a lot of different reasons. And I'm going to let you learn a little bit more about it right here.
Asteroid Bennu is a fascinating object. It records our solar system's earliest history, contains information about the origins of life, and has uncertainties in its orbit that leaves a small possibility of impacting Earth late in the 22nd century. These properties make Bennu the perfect target for NASA's OSIRIS-REx asteroid sample return mission.
It's a great adventure to explore an unknown world. We're going to reach out and touch it, and we're going to bring treasure back to Earth for scientific analysis. To me, it doesn't get any more exciting than that.
Well, I agree with that. And in fact, I sent my name and a picture that my son drew up to the spacecraft that's visiting asteroid Bennu. And that's one of the things you can do if you follow NASA on all these missions now. They can engrave your name on this little tiny chip that can be sent up on the spacecraft. And I think that's really neat. Anyways, this is what Asteroid Bennu looks like. You can see the picture at the very beginning of this presentation, and it's not round, as you can see. It's sort of, I don't know, like a square, and it's, you know, got a pink hue to it, and it's very, very rocky. As a matter of fact, Bennu is much more rocky than NASA believed, and they actually had a hard time trying to figure out where they're going to be able to touch down and grab the soil from the planet. Now, as I said, Asteroid Bennu is 1,600 feet wide. Well, how big is that? It's actually only a little bit larger than the Empire State Building, and even larger than, you know, the structure in France, the Eiffel Tower. Asteroid Bennu isn't very big, and it was a real challenge trying to figure out how to launch a spacecraft to learn about Asteroid Bennu. And there's a lot of reasons why they wanted to go to Bennu. And there's another video here, which is going to be kind of interesting. It's all about asteroids, fact and fiction, and especially about the asteroid Bennu.
What are asteroids? How much of the stuff we hear about them is science fiction, and how much is science fact? Join the 3-2-1 science team as we explore the solar system's space rocks. Asteroids have many different reputations. Science fiction views them as navigational hazards, colonization frontiers, and threats to the safety of planet Earth. Are these depictions anywhere close to scientific fact? Or are they just science fiction? First, what are asteroids? Asteroids are space rocks that range in size from a few meters up to almost 1,000 kilometers in diameter, like Ceres, which is so large that it is also called a dwarf planet. Most asteroids orbit in the main belt, a region of the solar system between the orbits of Mars and Jupiter. Astronomers have already discovered over 500,000 asteroids, and scientists estimate that the main belt is home to 1 to 2 million objects larger than 1 kilometer. With so many space rocks flying around, is the asteroid belt crowded, and is it hazardous to navigate? Nope. Although the main belt is full of millions of asteroids, space is so vast that they actually have lots of room. In fact, the average distance from one kilometer-sized asteroid to another is thought to be about 3 million kilometers. Asteroids aren't navigational hazards at all. Instead, scientists have to plan spacecraft trajectories very carefully to ensure that they will successfully encounter asteroid targets. Can successful encounters with asteroids lead to asteroid colonies or mining? Yes and no. Scientists think that the asteroids are remnants from the formation of the solar system, the leftover pieces that Jupiter's massive gravity prevented from forming into a planet. The asteroids are all much smaller than planets, and they don't have enough gravity to hold an atmosphere, nor do they have spinning cores to create magnetic fields. Without an atmosphere or magnetic field, an asteroid's surface is largely unprotected from the sun's heat and other cosmic radiation, making it inhospitable for life. Asteroids might be large dead rocks hard to live on, but they do hold promise as sites for mining precious metals and other elements. Some might hold hydrogen and oxygen that can be used for water and fuel needed for exploration and mining. Scientists and engineers are beginning to make plans to mine asteroids for these resources to use here on Earth and for outposts in the solar system. Are asteroids threatening to Earth? Not always. Long before asteroids seemed threatening, they brought water and the building blocks of life to early planet Earth. They started off friendly and helped Earth develop life. But, just as they brought materials early on, rare and large impacts caused mass extinctions, like the event that destroyed the dinosaurs about 65 million years ago. Even today, small asteroids fly by the Earth quite frequently. Astronomers have discovered over 1,000 potentially hazardous asteroids that might threaten Earth again someday. Scientists are studying these objects to learn about the threat of asteroid impact and what might be done to avoid the fate of the dinosaurs, or even smaller but still messy collisions. The OSIRIS-REx mission is sending a spacecraft to visit one of these potentially hazardous asteroids named Bennu. OSIRIS-REx will precisely measure Bennu's orbit and the small orbit deviations caused by sunlight as a result of the Yarkovsky effect, to determine whether Bennu will impact the Earth in about 200 years. And while it analyzes the future orbit, OSIRIS-REx will also map the surface and collect a sample of material that formed the building blocks of life, and return it to Earth to tell us about our origins and how useful asteroids can be for future exploration. Science fiction? Not this time. Science fact. You can learn more about OSIRIS-REx and Bennu by clicking on the links. This video is an OSIRIS-REx production. OSIRIS-REx is a partnership of the University of Arizona, NASA Goddard Space Flight Center, and Lockheed Martin.
Okay, so as I said, I find the asteroid mission, the OSIRIS-REx mission, very interesting for lots of reasons, and you could see why. It was launched in 2016, and as I said, we'll be touching down on asteroid Bennu to pick up a sample of the soil on October 20th of this year, and then we'll return that sample to Earth back in 2023. As you heard them say in the video, there's a possibility Bennu may come and hit Earth in about 200 years. So it's one of the major reasons we want to hunt for asteroids, because they can be dangerous and they can be causing a lot of destruction. This one asteroid right here caused a crater in Arizona, 1 mile across, 550 feet deep, and was traveling 26,000 miles an hour when it hit Earth. And the last time an asteroid this size came close to Earth was in 1976. But we know that there's an approach of a large asteroid about this big that could come here in 2028. And we're going to be talking about some of the asteroid mitigation programs that NASA is developing. There's asteroids not only cause damage to Earth, but asteroids can create craters on other celestial bodies too. So Earth's moon is just absolutely peppered with large asteroid craters. And as I said, that's why astronaut Ed Liu formed the B612 Foundation to try to hunt for asteroids before they come and hit Earth. You can take a look here on Mars and the craters on Mars and Venus, and even they hit other asteroids. And down here, asteroid Ceres, which Mary showed you on the video from the McAuliffe Center. Asteroid Ceres, you saw where that was in the asteroid belt. And this bottom right-hand picture shows the asteroid Ceres, which is actually about 500 feet deep. You stop and think about the fact that the average two-story house is only 20 feet tall. So that means if you could imagine 25 different houses stacked on top of one another, that's how deep some of these craters become. So this all comes to the question of whether or not an asteroid killed the dinosaurs. And I know that there's a lot of questions about that. And a lot of people say, I can't believe that one asteroid could kill off all the dinosaurs that were on Earth. So what happened about 65 million years ago is an asteroid that was almost 9 miles wide hurled into the section of Mexico in the Yucatan Peninsula called Chicxulub, and created a crater that was 100 miles wide and 18 miles deep. And we sort of knew that, back, I don't know, I think it was in the early 1980s. But there were a lot of scientists and researchers that wanted to learn more about it. So about 4 years ago, they went on a mission to find the crater. And they had a lot of big equipment, as you can see here. And they built this rig in the middle of the ocean. And right underneath, where you can see at the top photo, shows you where the Chicxulub crater is located. And in fact, one of the things that happened is after doing the research and taking samples from that crater, they actually brought it back to scientists and researchers in the United States. And just a couple of months ago, this is the report that came out from that mission.
For the first time, the very first time, we have a detailed picture of what happened in the 24 hours after an asteroid hit the Earth 65 million years ago. Were you there? Causing dinosaurs to become extinct. That's a joke. A research team led by the University of Texas at Austin made the new discoveries using rocks found off the Yucatan Peninsula. They say the blast ignited a chaotic day of fires, earthquakes, and tsunamis. That doesn't sound fun, leading to a prolonged period of global cooling. Derek Pitts is chief astronomer at the Franklin Institute in Philadelphia. Good morning. When I said that doesn't sound like fun, you go, well, maybe it was. This is a very exciting news for you.
It is very exciting news.
Big deal. Why?
It would have been great for geologists to have been there to see what actually happened. But the reason why it's so exciting is because here we have an instance in which scientists can actually get a really clear snapshot picture of what happened that day. This is the most eventful day almost in the history of the planet. This thing was 6 miles wide. It created a crater 90 miles wide, 18 miles deep, and it blew up 25 trillion metric tons of material into the atmosphere.
Wow. So we're learning more about our planet's past. Does it tell us something about the future?
Well, it tells us that this is not something that's isolated. We can have asteroid impacts in the future. Right now, we know there aren't any big asteroids that are anywhere near us, but small ones are still around that could cause problems for us.
You say it's all about location, location, location.
It is, because if the asteroid had not hit that particular location and in time, it could have been a very different outcome for the planet. That particular impact region at that particular time created this world that we have now because it altered the planet because of its impact there. If it had hit somewhere else, we could have had a different planet.
Scientists have looked at different rock deposits at the asteroid's crater. What have they found in this evidence?
So what they found in this evidence is that they know that the planet was the way it was at the time. They know that this huge impact created a gigantic tidal wave that washed across, this continent and really changed the face of the planet in that location, or really changed the face of the planet overall entirely.
And you are an astronomer. You are confident, and we're running out of time here, that there's not a big one out there heading our way?
No, I'm confident there is a big one heading our way. We do know that there are smaller ones, but we haven't been able to identify anything big heading our way. And we've taken a very good assessment of what's out there. Still more work to be done.
All right.
But we know there aren't any more planet killers out there in the next 1,000
Good.
years.
I'm glad to hear that.
We're safe for this week. Don't
Derek
worry.
Pitts, thank you.
All right. So we do know that asteroid that came and hit that area of Mexico back 65 million years ago did an awful lot of damage. The impact created a huge crater and a huge dust cloud that blocked out the sun for several months. And this actually started an extinction ball rolling because what it did, first of all, it killed off many of the world's plants. And then the dinosaurs that ate the plants, which are called herbivores, didn't have any food, and so they died off. And then the carnivores, which were the meat eaters, like the big T-Rex, had no food because the herbivores died off. And so what they're believing is that 75% of life went extinct just as a result of that. Now, I know there are still some people out there who don't quite believe that a huge dust cloud could create that much annihilation of what was then known as life on Earth. I want to take us in a different direction for a couple of minutes, and I have another poll for you. Okay, so Mary, if you could put up the poll, what do you think these two pictures are photos of? Let me see. Is it fog? Is it smoke from a fire? Or is it something else? What do you think that those two pictures are photos of? So let's see, we'll give it another couple of minutes. So those two pictures of fog, smoke from a fire, or from something else. Okay. A couple of people are saying smoke from a fire. A few people are saying something else. We'll give it about another, I don't know, maybe 10 seconds. Get an opportunity for a few others of you to be able to vote on that. Almost ready? 5, 4, 3, 2, 1. Okay, let's end the polling right now. And 70% of you think it's something else, and 30% of you think it's is the smoke from a fire. Now, I'll give you a little bit more of a hint with this next slide and see if you can figure it out. Well, that was pretty scary. All right. Do you have any idea what that is now? That's actually something. And let me play that. Let me see if I can go back and play that one more time. That's actually an event that happened 1 week ago today. And it's the dust storm from the Sahara Desert in Africa, Northern Africa, as you can see here. And that was a picture of the dust storm coming in and covering the island of Puerto Rico. So as you can see here, there's a distance of 3,500 miles between the Sahara Desert and the island of Puerto Rico. A week after the dust storm left the Sahara Desert, it actually covered the whole island of Puerto Rico for quite a few days. And if you've been following the news about the dust storm, then you know that it's on its way into the southern United States. It's hitting right now Louisiana and Texas and Mexico, and is going to keep traveling, might be traveling up through the United States. So it's a situation where when you stop and think and see a dust storm from 3,500 miles away and see how much damage it's doing and how much light it's covering from the sun, then it's a little easier to believe, in fact, what happened 65 million years ago. Now, one of the other things that has happened, another area that created some problems back in 1908. And this is the event that Asteroid Day today, June 30th, is actually celebrated for. And it's the day where the huge Tunguska asteroid explosion happened in Russia, right outside Siberia on June 30th, 1908. And the interesting thing is that it was felt as far away as England, which is about 6,000 miles away. Those trees that you see in the upper right-hand corner were on their side. 80 million trees were destroyed. And here it is more than 100 years later, and there's still no trees in the area. In that bottom left-hand picture, the trees are completely all gone and have never been able to regenerate themselves. So that asteroid explosion back on June 30th in 1908 sure did an awful lot of damage. Okay, so the question is there anything for us to worry about? You know, that's the big question. And I know it's kind of scary because, in fact, collisions of asteroids with Earth have occurred about every 100,000 years. And as you can see, even have hit the United States. Probably one of the most prominent ones, aside from the big crater in Arizona, was actually in Alabama, which surprises a lot of people to find out. I've got an interesting video. It looks like it might be scary as you start off with it, but by the end of it, you'll see that NASA has come up with some very interesting ways to prevent asteroids from damaging us in the future.
In 1954, Anna Hodges was hit by a meteorite.
What time of the day was this?
12:45.
12:45. And this comes through the roof and hit you.
She was napping when the rock crashed through her ceiling and bounced off the radio into her stomach. Because it was small, her injuries were minor.
Ever to be hit by a meteorite, imagine that.
But much bigger objects have collided with Earth. 65 million years ago, a rock 10 kilometers wide slammed into the Gulf of Mexico, an event that likely caused dinosaurs to go extinct. Elsewhere, mammoth meteorites have been discovered everywhere from the US to Russia, and blasted craters in North America, Australia, and Africa. Falling objects from the sky have always fascinated humans, but they have also made us fearful, making us wonder whether someday a giant asteroid could come for us. In movies like Deep Impact and Armageddon, those fears are played out.
1 minute.
And heroes save the day.
You know I gotta die, right? I'm the guy who gets to do it saving the world.
You might think this only happens in Hollywood, but that's not exactly true. There is a small chance, a really, really small chance of a large asteroid hitting Earth. So scientists are getting ready, just in case. Asteroids are hunks of rock that weren't big enough to become planets when the solar system formed. Smaller asteroids are called meteoroids, and when they fall through Earth's atmosphere, they become meteors. If they make it to the surface, they're called meteorites. Between 1988 and 2017, NASA counted over 700 fireballs created by objects entering our atmosphere. In order to detect asteroids, NASA takes multiple pictures of the night sky and uses computers to scan for moving objects. As Earth orbits, scientists make several observations from different locations to detect how close the asteroids are to Earth. Here, the nearest objects are labeled in green. At least 16,000 of them have been classified as near Earth, meaning they orbit within roughly a third of the distance from the Sun. And based on the object's speed and brightness, scientists can map a trajectory to predict whether it will collide with Earth. First, NASA could launch a spacecraft to act as a battering ram. And if the asteroid is far enough out, it would only need to be pushed a few centimeters off course to avoid hitting Earth. Right now, NASA is in the early stages of DART, the Double Asteroid Redirection Test, which will try out this approach by trying it on a non-threatening asteroid called Didymoon, which will pass near Earth in 2022. Another method would be using something called a gravity tractor, which pulls the asteroid in a new direction and points it away from Earth. Theoretically, a spacecraft could do this by hovering near an object to create a slight gravitational attraction that could be used to redirect the asteroid. The third option would be to go full Hollywood and use a nuclear device to vaporize part of the surface.
What you can do in principle, if you have a very powerful laser, is to cause jets of material heated by the laser to fly off of the asteroid, and that is essentially the equivalent of a jet engine pushing the asteroid off course.
So far, NASA hasn't found any asteroids big enough to threaten Earth, but we haven't been searching that long. There's still lots of space to survey.
Okay, so as I said, NASA's got several telescopes up there that are tracking asteroids. There's 15 in the ground-based telescopes here in the United States that have been surveying the sky for various durations. There's about 100 different telescopes all over the world that are doing this tracking. So we've got a pretty good idea of what's happening with the asteroids. There is a program. We were talking about near Earth objects, but there's another program called Potentially Hazardous Asteroid Program that's searching 5,000 miles away. Are they coming within 5,000 miles of us? Are they more than 460 feet in diameter? These mainly are coming from the asteroid belt. And I mean, you can look to the moon and see a lot of the impacts. One of the reasons why you don't see as many impacts here on Earth is because we have an atmosphere. And places like the moon and Venus and Mars and other areas around the universe, solar system, don't have atmospheres, but we do have an atmosphere on Earth. And so what happens is a lot of times these asteroids will burn up before they even get to Earth. And believe it or not, every single day, there's about 100 tons of micrometeoroids each day that come into Earth, but they get burned up in the Earth's atmosphere. All right, so Carl Sagan, astronomer, astrophysicist, and author, is quoted to have said, if the dinosaurs had a space program, they would not be extinct. And that would probably be very true. These guys, if they had the brains to have created a technology to deflect an asteroid, then we would be in a whole different area right now. But okay, so we just learned a little bit about how to stop an asteroid impact. We do have brains, we have a space program. So the bottom line is, and I can't emphasize this enough, don't worry about it. There's NASA and many other space agencies around the world have plenty of ideas and have already built many different spacecraft to be able to go up there and to stop asteroid impacts. So even Bennu, that might come to visit Earth in 200 years, by the time that may happen or may not happen, I think we'll be in a very good position to be able to deal with it. Okay, so we know about the potential destruction of asteroids, but what about some of the benefits of asteroids? And why else would we hunt for asteroids? Believe it or not, it's a good thing. There's asteroid mining. And in the modern day, we call it a modern day gold rush. So if you know anything about the gold rush many years ago, there were a lot of people who were finding gold and making a lot of money off of it. Same thing, and I think this is probably why Elon Musk is as involved in the space program as he is, because he wants to be one of the first people to go up there and be able to mine from asteroids. And metals like platinum are worth trillions of dollars. There might be water on Bennu. We know they've already discovered water on Ceres and Vesta. So if we're in for a long-term mission, then a spacecraft could potentially land on an asteroid, get the resources they need to continue on into deep space. So that's something that would be very good. One thing, I don't know if you can see the bottom of the slide there, but it actually currently costs, believe it or not, $20,000 to send a 1 liter bottle of water from Earth into deep space. So it would be very handy to be able to find water on other planets. The other thing that's happening, one of the other missions that's going to be launching in another year is the Psyche Mission. It's going to launch in 2022. And as you can see, that asteroid, which was on one of the early slides, that's an asteroid called Psyche. And so it's an all-metal world. It's very different from a lot of the asteroids that are up there. It appears to have a nickel-iron core, which would be extremely valuable. And so the goal of the Psyche mission is to explore a world that's not made of rock, but is made of metal. If you want to find some more information about the asteroid programs and what NASA is up to. I encourage you, and I can't encourage you enough, to visit the nasa.gov website. It has lots of information, not only for adults, but for kids of all ages. You can keep up with news about the space program, or if you're like me and you're crazy over asteroids, you can find out lots of information about asteroids and what's going on with NASA. You know, I really, really want to thank the Jet Propulsion Laboratory and NASA for having created this Solar System Ambassador Program. It's allowed me, who wanted to be, work for NASA in mission control back when I was a teenager, to be able to, in my age that's a little more than being a teenager, have the pleasure of being involved in NASA, even as a volunteer. I can't thank enough the McAuliffe Center. They've been a partner of me in a lot of my different adventures for many, many years, and I really do appreciate their input and their offers to get involved in their programs. And I think at that point, that's it. Do we have some maybe questions that we can have answered or discuss? Mary, can you come back into the picture?
Thanks so much, Pat. And yeah, it is now time for questions. So I apologize for not mentioning this at the beginning, but hopefully most of you have realized that there is a Q&A function at the bottom of the Zoom window. So those of you on Zoom, you should be able to see this Q&A button down at the bottom. You can use that to ask any questions that you might have. So everybody take a moment to locate that and start putting in your questions. So I am going to start with a question that's already come in, and I'm going to turn these mostly over to Pat, although feel free to send it back to me. But the question from Stacy is mining for these resources with respect to Elon Musk a sustainable choice? For example, would mining the elements create unknown imbalances as fracking has on Earth?
That's a good question, and I do believe that that's probably going to be true. There's such an abundance of metallic materials in particular, but other materials on these asteroids that it would take, let me see if I can stop sharing there. Okay. It would take a lot of the issues that we have on Earth, especially the fracking issue. I think it would take it away from the planet.
I think that you kind of alluded a little bit to how expensive also the process would be. So I think that's another kind of thing to think about in terms of sustainability. Like, is it a good use? Is it a efficient use of resources to try to get these resources?
Well, the abundance of the resources are just so much greater than anything that we have here on Earth. It's quite possible, and as long as we can mine those resources. And I know one of the things that I've looked at is the Artemis program, which is the mission back to Mars. And how one of the things that NASA wants to do is figure out, before they jump onto Mars or to other planets or asteroids, how can they take advantage of the resources that are on the moon to be able to use them and make them more sustainable. So I think with that comes some efficiencies that we're not even thinking of right now.
Okay, another question that's come through here. Were there any eyewitness accounts of the Tunguska asteroid effects? Do you know anything about that, Pat?
Yeah, actually, there were a couple, and they were able to get some of these witnesses. There was one gentleman in particular who lived, I believe, about 80 miles away from there, who said his clothes were completely burned off. And it happened at 7 o'clock in the morning. He was outside on his porch, and he said he saw something fiery come from the sky, and this big boom that created, a big tremor, but his clothes got completely burnt off. And there was another one I remember reading that was further out than that, a couple of 100 miles away from that, where people reporting, seeing the fireball in the sky, and hearing a big explosion.
All right, so any other questions from the audience? You know how to enter them. All right, well, some questions coming in. All right, we have a question from Shreya, I believe, I hope I'm saying that right, or Shreya, who is a second grader. And the question is, what is Psyche? What does it have in it?
Well, Psyche is an asteroid that's currently in the asteroid belt. It's not out of the asteroid belt and isn't a danger to Earth at this point, even though it might be 500 or 600 years from now. But it's made of a metal that would be very valuable to Earth if we could figure out how to dig into that asteroid and obtain the metals that are there, even though that's probably not going to be likely to happen in the foreseeable future, because the Psyche mission doesn't launch for another 2 years, and it'll take probably 5 or 6 years to reach the asteroid. So by the time we get the information back about how valuable Psyche could be, as a second grader, you might be able to get involved in a mission like that. By the time you're, in your 30s or 40s, it might be something that, if you're interested in the space program, it would be something really, really interesting. I would find it very interesting to get involved with.
I definitely think there's a very good chance that the Psyche mission will still be going on when this person is an adult. Great question. Okay, so I just got a really fun question. I hope that Pat has some responses. The question isn't really about asteroids, but what are the other possibilities as to how the dinosaurs went extinct other than the asteroid theory? Do you know anything about that, Pat?
I try not to. And the reason for that is because I do believe in that theory. But, it could have, in these days of COVID-19 right now, there could have been some sort of a virus or bacteria that got into, a couple of dinosaurs. And then, as they were roaming around, they could have developed a contagion for it from other dinosaurs, especially, back then. It's not like, you go to the refrigerator now and you eat the food from the refrigerator. Back then, the bigger dinosaurs were eating the littler dinosaurs, whether they were herbivores or, carnivores. But I'm not sure about other possibilities. Have you got any information on that, Mary?
No, I don't. But I think that what Pat is trying to say is that, sure, that is possible, but I don't believe there's any evidence to support any other ideas. So that's what we try to do as scientists, is see where the evidence points. There are probably lots of possibilities that could have occurred, but the evidence really points to this theory. The Chicxulub crater is one really strong piece of evidence, and the rocks that they found there. I think that probably what's kind of an area of confusion for people is thinking that they all got killed by this impact, which is not the case, as you described. It's that the dust that was put up into the atmosphere. Certainly, I'm sure many did if they were in that region, but the dust that was put up in the atmosphere caused this chain reaction, is the theory.
Well, you know, there's a wonderful program on PBS that I saw probably 6 or 7 months ago that talked about the theory of an asteroid wiping out the dinosaurs. If you ever have an opportunity to watch that, I'm sure PBS runs it on a regular basis. It is probably one of the best programs I've seen about that theory. And then the information that's just come out from, as I said, the research that they did in the ocean back 4 years ago and just got the results from a few months ago, just further supports that theory.
Absolutely. I think that maybe we have time for probably about one more question because people have been coming in with questions now. So the question is, do you think any of the substances on these asteroids could help solve some issues on Earth? Natural disasters relief, medical advances, or building houses in certain areas where usual building materials is unsustainable, or maybe even help with cropping and food service.
You know, there's so much that we don't know about what's on the asteroids yet, and what material can be found on the asteroids. As I said, the Hayabusa 2 mission that Japan launched several years ago will be bringing back the first samples of materials that can be found on the asteroids. We know that, you know, on the International Space Station, there is an awful lot of work that's been done and a lot of materials that have been found to help advance the medical community and technology. It's just been absolutely amazing. So I think once we send more missions up to asteroids and get the results back about the materials that are available, I think it's something very definitely that could help us here on Earth.
Great answer. Great answer. Do the exploration first and that's why we do it. It's one of the reasons.
Why we do it.
Okay, so I think we should probably wrap up for today. But I did want to, first of all, say that anyone who didn't get a question answered, these do get saved. And we're always looking for, we're coming up with a scheme to answer some of the common audience questions that we've gotten in the past. So please stay tuned. And I do want to remind everyone of our website once again. So our main website, cm-center.org, and then I also just put up our asteroid day page. So should anything come up related to this talk that we might want to post, you'll find it there. And if you go there today, you will actually find a couple like activities that you can do. Pat usually does these things in person and always likes to recommend activities. So we have those on our website. And then we do also have another talk later today with a different speaker. So check that out. I want to say thank you everyone for coming. And most of all, thank you so much, Pat, for joining us. Probably a different Asteroid Day experience than you've had in the past, but very fun nonetheless. So,
yeah, I'm so, as you said, I'm so used to doing these presentations in person. And, you know, you see your audience looking back at you and asking questions and the activities. This is a very different experience.
Well, we're really grateful to have you. So have a great evening, everyone. Happy Asteroid Day. I hope that after this presentation, you do feel like it's a pretty happy day. Nothing to be too worried about. And we hope that we'll see you at future live virtual events hosted by the McAuliffe Center.
Thank you.